In this video we're going to study inclined planes. Some people call them ramps. Inclined planes are a simple machine, and like their name implies, a machine makes a job easier. And what an inclined plane makes easier is getting an object like this yellow block up to a certain height. So the physics behind it is that it requires less force to push this yellow block up the ramp to this height than it would be to lift it straight in the air. And so that's why they're known as a simple machine. It makes lifting it easier. And coming up in physics, we're gonna learn a lot about the inclined plane and see how they affect the motion of a block that's sitting on it. And so we really have to get used to drawing the free body diagrams, which can be the most complicated part when you're first learning about them. So like this problem says, it says draw the free body diagram for the block on the inclined plane shown below. And so we're going to start with the force that we're all familiar with. That's the force of gravity. And so if we draw in the vector for the force of gravity, it goes straight down, if I can draw a straight line, straight down toward the center of the earth. And so I'm going to put force of gravity here. Another force that we're familiar with is the force of the ramp on the block, and that's goes perpendicular to the surface of the ramp. So if you imagine this was a right angle right here, and this is called the normal force. Notice how the normal force does not go straight up. It's always perpendicular to the surface of whatever the object is on. And so that's our normal force. And we know that the block, if we just let go of it, is probably going to slide down. The motion of the object will be down the ramp. And so we know the other force that opposes motion is the force of friction. So force of friction will be pointing up the ramp. Okay, and then we know that there's got to be some force here that's pulling the block down the ramp. It's not the force of gravity, exactly the force of gravity, because that's going straight down, and we know that the block isn't going to move straight down through the ramp. And so there's a little trick here that we've got to use to figure out what the force is that's pulling it down the ramp. And that little trick is if we take the force of gravity vector and divide it into its two component parts. It's got a y component and an x component. And so what I'm going to do is continue this this normal force and go straight down through the ramp. Okay, I'm going to draw a dotted line straight down this way. And so that's the component of gravity in the y direction. And then if we look at it, the component of gravity in the x direction would be right here. And so this forms a right angle. And so what we did there was made a triangle. The force of gravity is always going to be your hypotenuse. All right? And so what we call this up and down side of the triangle, we call this the force of gravity in the y direction. And we call this a leg of the triangle the force of gravity in the x direction, because it's more left and right, and this leg is more up and down like the y-axis, and this one's more left and right like the x-axis. And so these two forces here are the components of gravity. And what you'll notice is that this component of gravity, this FGX, is parallel with the ramp. And so that is the part of gravity, that's the component of gravity that's pulling it down the ramp. So your force of gravity in the x direction will pull it down the ramp. Okay. And another thing we've got to talk about is this angle. The angle of the ramp here is 30 degrees. If you imagine, let me outline this triangle here. Let's just talk about this triangle. It forms a right angle right here with the force of gravity line. And so if we look at this triangle, that would be 30 degrees. This is 90 degrees. And the triangle has 180, so 180 minus 90 minus 30, what's left is 60 degrees. That's a 30, 60, 90 degree triangle. And the reason that angle is not so important to us, what we want to find is this angle. And so let me call this theta. If we look at this part here, this was perpendicular to the surface, so we know that this angle is 90 degrees. Well, if we've already used 60 degrees of our 90, this one has to be 30. And so that's just a trick to find the angle of this triangle. Another thing that you can always remember is that this angle right here will always be the angle of your triangle that you drew. So I'm going to erase this 60 so we don't get confused with it. So whatever this angle of the ramp is, goes in right here. Okay. And so another thing to be aware of when we're working with inclined planes is that your force of gravity in the y is also going to be equal to your normal force. So the normal force is equal to the force of gravity in the y direction. And the force of gravity in the x direction is what's pulling the object down the ramp. So it's the force that's pointing down the ramp. Okay, and I think if we keep our forces that we've just drew in this free body diagram, if we keep them straight, we'll be able to solve these problems. Let's look at a real problem that we're going to solve involving inclined planes. So this problem says, find the acceleration of the block shown below. The coefficient of friction is 0.25. Okay, and so we're going to start by drawing our free body diagram. We know that there's a force going straight down toward the center of the earth called the force of gravity. Okay, we know that there's a force going straight perpendicular from the surface of the ramp going straight up called the normal force. We know that there's going to be this force of friction that's opposing the motion. The motion's going down the ramp. And then if we draw our components of gravity here, so this dotted line is going straight down this way, and then if we make a right triangle here, we call this one the force of gravity in the y direction because it's more up and down in the y-axis, and this one the force of gravity in the x direction. And if you remember, this angle right here will also be the angle at the top of this triangle. Okay, so now the force of gravity in the x, since that's parallel with the ramp, that's going to be the part of gravity that's pulling it down the ramp. So we'll call this force of gravity in the x direction. And now we have all the forces. Let's go ahead and put in the magnitudes of those forces. So the force of gravity is always equal to mass times g. And g is the acceleration due to gravity, which is 9.8. So 10 times 9.8 will give us 98 newtons. So the force of gravity is equal to 98 newtons. All right, and now we're going to use our trig functions to find force of gravity in the x and force of gravity in the y. If you remember, SOHCAHTOA will help us do that. So if we want to find the force of gravity in the x, that's opposite that angle, and we already know the hypotenuse. So opposite and hypotenuse, we're going to use sine. So sine of 30 degrees is equal to opposite, which is force of gravity in the x, divided by the hypotenuse, and that's 98. And so times each side by 98, so we get 98 sine of 30 is equal to FGX. So let me put that in my calculator. 98 times the sine of 30 is equal to 49. So force of gravity in the x is 49 newtons. So I'm going to put that right here, 49 newtons, and also right here, 49 newtons. And now let's find the force of gravity in the y direction. We notice from this angle it's the side closest to it, or the adjacent side. And we do have hypotenuse, so let's use cosine. So cosine of 30 is equal to the force of gravity in the y direction divided by, so that's adjacent, divided by the hypotenuse, which was 98. And so again, timesing each side by 98, 98 cosine of 30, so 98 times the cosine of 30 is equal to 84.9. 84.9 newtons. And so that's what the component of gravity in the y direction is, so 84.9 goes here. And also the force of gravity in the y equals the normal force. They're on a straight line, so this is the force down, and the force up would be the normal force, so that's 84.9 as well, because it's not moving. Those forces have to be balanced. And so now that we have the normal force, we can find the force of friction, which is equal to mu times the normal force. And we told us in the problem that the coefficient of friction was 0.25. So 0.25 times 84.9 is equal to 21.2 newtons. Okay, and now we've got all the forces and all the magnitudes labeled, and so we can go and try to find the acceleration that this block will experience. And whenever you see acceleration in these physics and force problems, you think Newton's second law, which says the net force is equal to ma. Okay, so let's look at the net force here. There's not going to be a net force in this direction, up and down, because the forces are balanced. So let's look this way. I'm going to call down the ramp positive, and I'm going to call up the ramp negative. And so all the positive forces here are 49 newtons. Subtract off all the forces that are going up the ramp, which is the force of friction, which was 21.2 newtons, and that's going to be equal to the mass of the object, which was 10, times its acceleration, a. And so 49 minus 21.2 is equal to 27.8, and that's going to be equal to 10a. 10 times the acceleration. So to get acceleration by itself, you divide each side by 10, so 27.8 divided by 10 is equal to, so acceleration is equal to 2.78 Newton, and acceleration is meters per second squared. So that's what the acceleration of this block will be, 2.78 meters per second squared. All right, so hopefully that helps you kind of figure out how to do the math on some of these inclined plane problems. What I've got for you for your video physics assignment is 2 problems very similar to the ones we just went through in this video. And so there'll be 2 problems that follow. Again, if you get confused, go back through the video. You can watch it again or stop by anytime and I'll help you out. But yeah, I'll scroll through them very slowly. There's 2 problems that will follow, and good luck.